Okay, you're good. Okay, good morning, everyone. So before we let Fajardo start his presentation, I would definitely like to take this opportunity to give him a short introduction and recognize the accomplishment that he made for the last more than 2 years, I believe, being with Thesis. So Hector Fajardo joined in fall 2019, right? And he's from Bolivia, and throughout those years that he's been here working, he's just had a lot of recognition, among which included the ASSCT Fellowship Award for 3 years. He was also recognized as the 2020 Phi Kappa Phi Honor Society LSU Chapter Outstanding Master Student. Just this year, he received the Louisiana Agricultural Consultant Association a scholarship award as well. And he did win the 3rd place for his presentation at the ASA, CSSA, and SSA virtual. That's virtual in 2020, right? For the cover crops community management, which he's going to talk about more because this is focused on his master's thesis. He's bound to pursue his PhD at North Carolina State University in fall this year. So without further ado, I will give this stage to Hector Fajardo to have his presentation shared to everyone. And also after that, anybody from the audience are welcome to give him, throw some questions to Fajardo before we start the defense proper.
Okay, so I'll go with the presentation, right?
Yes, go ahead.
Well, good morning, everyone. Good morning, dear committee members, professors, and the audience, and the people that it's online. I think they can hear me. I hope so. So.
And you can check, Fajardo, you can check. I'm just making sure they hear you.
But I need to finish.
Yeah, that's fine. That's fine.
We can hear you.
Oh, that was awesome.
Yes, thanks.
Okay. Okay, so as Dr. Johanna mentioned, I will present my master's research project. And the title of it is Cover Cropping Sensor-Based Estimation of Biomass Yield and Nutrient Uptake and its Impact on Sugarcane Productivity. Let me first introduce some background concepts that are needed to see what was the need for this project, or what is the need for this project too. I will start mentioning something related to the sugarcane production system here in Louisiana. Usually, we replant sugarcane between every 3 to 4 years. And this is mainly because of the decline of the yields, because of the crop age. And also, this is related to the cost related to this practice, which is basically the main input or the main investment. But in this process, because we replanted every 3 to 4 years, we have a gap of almost a year since the last harvest until we plant. In that period, we have very small or little coverage on the soil, and that's for the fallow period. And this creates a great risk of soil degradation and yield decline. And as you can see in the bottom of the slide, there's a small calendar where you can, on the left, you see the last harvest until the fallow period, the planting time, and the first harvest of the new planted cane. Another concept that we need to consider is what is cover crops. And Here I present a concept that attracted my attention because it was reported more than 100 years ago. Because there has been a lot of interest in cover crops recently, but especially, I mean, in my opinion, there have been other scientists that have reported this practice way before. Morgan and Taylor define a cover crop as a crop that usually is planted in the late summer or autumn, and that will provide a green cover that will be growing during the late autumn and until the winter months. And this is the case for winter cover crops. Now I'm displaying some pictures of what is a field with cover crops and without cover crops, or a field with bare soil. In these ones, you can see how cover crops are being planted in sugarcane, with a purple line showing where the cane was planted in the bed, and the yellow lines show how the cover crops are on the shoulder of the bed. And another picture later in the season where the cover crops have already grown and the sugarcane is starting to get back into the active growing period. Now, cover crops have different benefits. One of them are their role into nutrient uptake or nutrient cycling. So for this, the advantage of the cover crops is that they extend the growing season, providing coverage of the soil. And by having this coverage and this input of organic matter into the soil, we can enhance the soil health while improving the soil properties or the soil characteristics. During this growing period, these cover crops are going to take up nutrients during the winter months, and they are going to release it during the decomposition of this green organic matter. Later, that will benefit the cash crop. In this case, the objective was to benefit the sugarcane. And as you can see, the same calendar plus the addition when we planted the cover crops during the late fall until the winter. So we add some soil coverage in this period as well. Another concept that I need to mention is what is remote sensing and what is it important in agricultural systems. So remote sensing is the process of gathering data, in this case reflectance data, out of any surface. In this case, from the crop or from the vegetation surface. And from this reflectance data, we compute vegetation indices. And the advantage of these indices are that they can help us estimate plant biomass and nutrient uptake. Moreover, another advantage is that this is a non-destructive method. So we can have an estimate of these variables without affecting the crop at all. And between all of these indices, I would say that the one that has been studied the most and one of the most common ones is the normalized different vegetation index. And as you can see in the bottom, Tucker displayed this index as the difference between the near infrared band minus the red band divided by the addition of both bands. So with all of these are the main ideas or concepts that revolve this project. And for this, we established two objectives. The first one was to evaluate the use of NDVI to predict the cover crop biomass and nutrient uptake. And the second one was to determine the impact of planting method and seeding rate of cover crop on soil nutrient level and on sugarcane yield and quality components. So let me start with the first study, which is the evaluation of the use of NDVI to predict cover crop biomass and nutrient uptake. For this study, we set up several sites at the LSU Ag Center Sugar Research Station in St. Gabriel, Louisiana. And we impose different treatments, which were two different planting methods, which is one was broadcasting the seeds, and the other one was drilling them. And also we use three different seeding rates. We use as our base the NRCS recommendation. We took that recommendation and we use half of that recommendation, which is translated to 50%, and a quarter of that recommendation, a smaller rate, which is the 25%. And we left some plots without cover crops so native weeds can grow in there. The idea of having this combination of different planting methods and rate, it was to create different cover crop stands. And by having different stands, we will have more variability, or we will have more points to create a model, to establish a model that later on I will display the result. And in these experiments, in all of these experiments, we use a mix of 5 species. 3 of them were legumes and 2 of them were brassicas. The legumes were crimson clover, balanza clover, and hairy vetch. And the brassicas were tillage radish and rapeseed. For the sensors that we use 2 different sensors. One was a passive one and the other one was an active. The passive one was a multispectral camera. In this case, we used the Red HM camera developed by MicaSense, and we mounted this camera on a DJI Phantom 4 drone. And on the other hand, the other sensor was the Green Seeker developed by Trimble. In the presentation, you will see 2 tables where we describe the bands that each sensor can get information from. So for the multispectral camera, we have 5 different bands, RGB plus near infrared, and also the red edge. And for the Green Seeker that we use in this project, we have 3 different red bands and the near infrared one. For computations later on of NDVI, in the case of the multispectral camera, we use band number 3 and band number 4 on the table. And for the NDVI from the Green Seeker, we use band number 1 and band number 4. Now, going through the methodology that we follow in those experiments, first we get the cover crop biomass collection. And we did this through the quadrant frame method. So basically, we use 1 square meter frame, and we throw it randomly in the field. And from there, we clip all the cover crop biomass above from the soil. And we separate each species in a different paper bag, with the exception that we separate the tillage radish into 2, 1 for the roots and 1 for the leaves. And yeah, we did this approximately 1 week before the cover crop termination. The sensor data analysis and how we gather it. So in the case of the Green Seeker, after we throw the frame, we went with the sensor and get the readings. Later on, we collect, we remove everything from the field, and we fly the drone for the first time to get the NDVI values. Later, in order to match the points from the Green Seeker with the UAV, or the aerial imagery, we fly for a second time after clipping the cover crops. And after clipping, in order to create more contrast, we place red panels on the field, as you can see in the image here. And by doing this, we have the chance to match the NDVI readings from the drone with the ones with the Green Seeker. For the aerial imagery, we develop a flight plan on drone deploy. We build the orthomosaic on Pix4D, and later processing of the data was done in QGIS. For the nutrient content analysis, we carried two analyses. The first one was the CN dry combustion method. In this project, we used it, we did this through a LICO machine. And the other method was, for the other nutrients, was the nitric acid and hydrogen peroxide digestion method, followed by the ICP analysis, or inductively coupled plasma analysis. So let me start with some of the results. Here are some of the climatic conditions in which the cover crops were grown. So for the first year, we planted the cover crops in November of 2019, and we terminated them in March of 2020. In this period, we have around 460 millimeters of precipitation, and the lowest temperature was recorded in January with 13.6 degrees Celsius, and the highest was recorded in March. For the second year of experiments, we planted the cover crops between September and October of 2020, and we terminate them around March and April of 2021. In this period of time, we have approximately 770 millimeters of precipitation, and the lowest temperature was recorded in February with 10 degrees Celsius. And it's worth to mention that in this month, there were 2 freeze days that, if you remember, even LSU closed those days. So there were some impact from there. Here I'm displaying the biomass results of the cover crop stands. As you can see, I separate them by the treatments that we impose, but approximately most of them were around 500 kilograms per hectare, but there was a big range of data points. As you can see, we also obtained values higher than 3,000 kilograms per hectare. In order to characterize this, the growing period or the growing season, and also in order to combine all the data, we decided to obtain this, to standardize the conditions by getting the data from each site, where we obtain the number of days since planting the cover crops until we get the sensing data. And also, we also get the cumulative growing degree days from the same time period, and our third variable is the number of days with positive growing degree days in the same period of time. Okay, so there you can see the values of these 3 variables. So in this slide, I'm showing the relationship between the readings from both sensors. On the top left, you will see the regression, the correlation between the simple readings from the green seeker versus aerial imagery. And we obtain a value of coefficient of determination of 0.63, which means that NDVI from green seeker was able to explain around 63% of variability of the NDVI obtained from the aerial imagery. Moreover, the analysis was significantly, in terms of statistically significant, which means that this approach of having a linear relationship between these 2 variables, it's a good one. And figures B, C, and D are the normalized NDVI, which sounds funny, normalized index. So on top, we have the normalization of NDVI through the number of days. Figure C is the normalization of NDVI divided by the cumulative growing degree days. And figure D shows the normalization with the number of days with positive growing degree days. As you can see, in these three cases, the R squared got increased, meaning that the variation, the linear relationship was able to accomplish more of the variability. So the way I see this is that the linear relationship, which in this case is it's an empirical approach, plus the addition of a deterministic value, in this case, the normalization or the standardization of the growing period, increase the accuracy of, in this case, the relationships. Now, the comparison between the NDVI readings through the biomass. On the left, you will see the relationship with the green seeker data. And on the right, you will see with the aerial imagery. In this case, we yield a R square value of 0.45 and for the green seeker, and an R square value of 0.17 for the multispectral camera. Something that it's worth to mention is that, first of all, the green seeker was able to accomplish more of the variability. And this the reason behind this might be the ambient conditions and also the sensing approach that each sensor has, mainly the difference between an active and a passive sensor. In this case, the active one was able to show better relationship. And another problem that we find by doing this is that we got saturation issues of NDVI. And as it was reported in the past, for example, Rod and Steer in 2017, they mentioned by measuring NDVI on cover crops that around 0.7, they got issues on saturation. And we have a similar trend here. And also we see that data points that are above 2,000 kilograms per hectare are kind of misleading the regression. Now, the case for nitrogen uptake, in the same way, the green seeker was able to perform better than the multispectral camera. The coefficient of determination of the green seeker was 0.35, and the one for the drone was 0.08. Similar tendency where the active sensor was able to fulfill more of the variability. Later on, with the macronutrient content in the cover crop biomass, here in this table, I'm displaying all the macronutrients. And in this case, we obtain good relationships for potassium and phosphorus, where obtained the higher coefficient of determination values. And the reason behind this might probably be that these nutrients are concentrated, have a higher concentration, so they are more sensitive for sensor readings. Later, we obtain a fair correlation with magnesium, and this could be attributed because this element is also associated with chlorophyll production in the plant. And we didn't obtain good relationship for sulfur and calcium. It was reported in the past that sulfur was difficult to be related with any vegetation index. And in the case of calcium, it has been reported in the past that it's easier to see toxicity problems in calcium in plant, and that was able to be catched by a sensor rather than when calcium is in a normal range. Now, a similar table, but in this case for the micronutrient content. Here, the higher correlations were obtained for magnesium and copper, as you can see. And this is attributed to the fact that these two elements, whenever there's a deficiency symptom, there's a chlorosis effect on the plant. So this means that any variability in this nutrient will affect the color of the plant, which means that it can be catched faster or easier by the sensor. We obtained fair relationships for molybdenum and nickel, and contrary to previous studies, we didn't find a good relationship for iron and zinc, and this could be attributed because in previous studies they use different sensing techniques and in different environments. Most of them were under better, like more protected growing conditions. Maybe most of them were in a greenhouse, and also for the mobility of these nutrients in the plant. And lastly, we obtained a good relationship for boron, but this might be because the plant tissue analysis was not sensitive enough to see the variability, so it created a noise in the data set that in this case benefited the linear regression. But in the past, it has reported that there were not good relationships. So with all of this, I would like to give the conclusions of this study. So first of all, we obtained a good correlation between both sensors. And the normalization of NDVI through the variables that I presented before improved this correlation. Also, it's worth to mention that NDVI derived from the green seeker obtained a stronger linear relationship with dry cover crop biomass and nutrient content compared to the NDVI derived from the aerial imagery. And we obtained relative good correlations between NDVI and some nutrients. In this case, in the case of macronutrients, we are talking about potassium and phosphorus, and in macronutrients for manganese and copper. Now, let me start with the second study. In this case, the title of the second study is the determination of impact of planting method and seeding rate on soil nutrient levels and sugarcane yield and quality components. The same, we place 5 sites at the sugar research station from the Ag Center in St. Gabriel, Louisiana. And we have these 2 planting methods and 3 seeding rates. And also we have plots without cover crops, so native weeds could develop over there. In this case, the objective of having different cover crop stands is to have different amounts of cover crop biomass incorporated into the sugarcane system, and based on that, see the effect on soil nutrient content and sugarcane yield and quality parameters. We use 3 legumes and 2 brassicas in all of these experiments. We use them in a mix. For the soil nutrient content, we gather composite soil samples made out of 16 soil cores, and we took 2 different soil depths. The first one being from 0 to 15 centimeters, and the second one from 15 centimeters to 30 centimeters. In order to obtain the soil in organic nitrogen content, in other words, the ammonium and nitrate concentration, we did it through the KCl extraction procedure, followed by the flow injection analysis. And for the rest of the nutrients, we did the Melick tree extraction procedure, followed by the ICP analysis, or inductively coupled plasma analysis. In the case of the cane yield and quality parameters, cane yield was acquired for each plot with the head of a chopper harvester and a dumb billet wagon. And from each plot, we took stock samples, cane samples, and we gathered them, and these samples were shredded and analyzed by the spectra cane automated near-infrared analyzer. And from there, we obtain the quality components of the cane. Now, as part of the results, let me give you a brief description of the climatic conditions during the active growing period. So, for the first year of experiment, we plant the cane in September of 2019, and we harvest the plant cane in November of 2020. During this period, we obtained 1,329 millimeters of precipitation. The lowest temperature was recorded in November, and the highest temperature was recorded in August, being in August around 29 degrees Celsius. For the second year of experiments, we planted the cane in August of 2020, and we harvested on December of 2021. During the active growing period, we obtained 1,842 millimeters of precipitation. The lowest temperature was recorded in November, and the highest was recorded in July, with close to 28 degrees Celsius. Now, in the slide, you will see one of the sites and the results obtained for cane yield, sugar yield, and the quality parameters. And it's worth to mention that even through all the site years, in this case, without considering the year or even the crop age, in general terms, we didn't see any statistical significance for cane yield and sugar yield. So here, as you can see, this is just one example. In this case, this is site 1. And all the values are above the pre-established alpha value or the p-value. However, there were two sites. In one site, we see a difference in terms of cane yield, where the broadcast performed statistically higher than the drilling. And in another site, we see that there were a difference in quality components. In this case, it was site 2, but we see the effect in the first ratoon and not in the plant cane. And as you can see, the seeding rate have an impact on the quality components. In this case, something interesting about this is that the higher values of the quality components are from the plots that didn't have any cover crop planted on them. And the lower values of quality components were obtained in the ones that received the higher rate of cover crops. Now, let me show you the nutrient content in the soil. As you can see in the graph, here I'm displaying from one side for plant cane and for the fresh ratoon. And over there, in this case, the nitrogen, we have divided by different planting methods and seeding rates, and them are divided by the form of the nitrogen, either in ammonium form or either in nitrate form. It's worth to mention that there were no statistical difference at all between the treatments. But here you can see the pattern of the nitrogen through the time. Similar results were obtained for phosphorus, where we didn't find any difference or any statistical difference between the treatments. But I mean, here you can see the fate of, not the fate, but the concentration of phosphorus through the time, from the plant cane till the first ratoon. The same for potassium, where in the same line we didn't have any statistical difference between the treatments in between each sampling time. the same for sulfur. There were no statistical difference. And in this case, I'm just showing one side that we only have the data for the plant cane. And the same pattern for calcium and for magnesium. We didn't see any difference created by the imposed treatments. So with all of this summarized, we can say that there were no significant effect, especially considering a p-value lower than 0.05, in terms of sugarcane yield and quality components on plant cane and the first ratoon. So far the data that we have didn't show any difference. And there were no significant effect of in terms of soil nutrient content between the treatments. So in order to wrap up everything together, let me give you the general conclusions of the whole research project. So we find good correlations between the sensors. The relationship was improved through normalization of the NDVI values. GreenSeeker performed better than the aerial imagery in order to being able to explain dry biomass and nitrogen uptake. However, we see some saturation problems that affected both sensors, but in different magnitude. Finally, we can say that NDVI, the linear relation of NDVI was good for some macronutrients and also for some of the micronutrients. In general terms here, I can say that GreenSeeker as an active sensor performed better than the multispectral camera. But in order to choose a sensor, I mean, the aerial imagery have an advantage of being able to gather data for larger areas faster and without the need to get into the field, right? So, I mean, it's debatable. And we obtained good sugarcane stands, even with the intercropping system that we imposed in these experiments with the addition of the winter cover crops. No effect from planting method and seeding rates were found in terms of sugarcane tonnage and sugar yield, and as well for quality components. In terms of soil nutrients, this varied between sites, years, crop age, and sampling dates, but there were no significant effect by the planting method and the seeding rate. And I can say that this reaffirms the long-term effect of cover crops in terms of nutrient management and the effect on yield and, in this case, the quality components of the sugar. So I would like to thank, well, the College of Ag, the Ag Center, the soil fertility team who have helped me through all this time, some of the, I mean, the American Sugarcane League, and the Patrick Taylor Foundation. Yeah, that's my presentation. Thank you.
Okay, we will open the program for questions from the audience, general audience.
Should I?
Yeah,
put
you
the
can
teams, right?
minimize it so you can see if there's questions on the chat.
Yeah, there's chat here, right?
Hey, Hector, nice presentation. I'll ask a question if that's okay.
Okay. Yeah.
All right, so I thought it was a really interesting presentation, and I'm curious, for the first study in which you were showing the relationship then with different imagery and DVI and then the nutrients in the soil, Do you think that what you observed would extend to other areas, or were your results rather specific to your study site?
Yeah, that's a good question. The short answer would be that these relationships might probably be useful just under these certain conditions. But because it was an empirical approach, so we will need to have more sites and more site years to being able to accomplish more variability in order to have a model that can be applied in different places or under different conditions. But as I mentioned, the addition of a deterministic factor into the model improved the accuracy of the model. So that means that maybe a mix of both approaches will be more helpful in order to develop a better model or better prediction at some point if we continue working on this. I don't know if I answered your question.
You did, yes, thank you.
Any other question? Comment?
Question?
About your sites, they are not separated much, right? In the same plant area, right?
Yeah, I mean, all of them are in the sugar station.
Right, so it's like replications rather than treatment.
Yeah, the sites.
Yeah, because it's set up within the plant area, same plant area. Am I right?
Yeah, I mean, in terms of sites, I forgot to mention that there are some sites that have a heavier texture and others have a lighter soil texture. But I mean, sites, the way I see it, I mean, because they were planted in different years also, so I don't see them I mean, they can be a replication, but they are also affected by other factors like the growing conditions and the rest. So I won't treat them as replications.
So were all of your treatments replicated at each site?
Yes. Every treatment has 4 replications in each site.
So one site, for example, site 1 was done in first year.
Yes,
Site 3
sites 1 and 2 were planted in 2019, and sites 3, 4, and 5 were planted in 2020.
Okay, so
Yeah.
they are not replicated in each multi-year.
Yeah.
I see. That's the reason that your growing degree day was deeper.
Yeah.
Okay, that makes sense.
And also there was a difference. For example, let's compare it size 3, 4, and 5, which it was from the same year. But in the case of 3, we planted the cover crops and we didn't have any problem. So we planted them in September. And the objective was to plant them in the same period for the other 2 sites, but we had some issues with herbicide residue. So we need to replant them. So we delayed the planting for 1 month. So even in that year, we have variability. And also in terms of cover crop termination, for some of those sites, we terminate them first and others later. So that's why we have different numbers of days, and that translates to different growing degree days.
The earlier part of your presentation, you select 2 band type for each instrument, right?
Yes.
What is your reason for select 2 bands and not use all of them?
Well, the reason to select these 2 bands is because we were comparing one index. In this case was NDVI that only uses these 2 bands. And the reason to use NDVI is because it's one of the more common ones. So, it's widely used, and also it portrays, it represents better the standing or the healthiness of a crop. So yeah, I don't know if that answered your question, or why each band exactly. The red band is usually related to the absorbance of the chlorophyll. And the near infrared one is related to the living cells in the plant. So whenever you have a healthy stand, you will see less reflectance of the red band and higher reflectance of the near infrared. And if you have an unhealthy plant, you will have a higher reflectance of the red band and a lower reflectance of the near infrared one.
You mean to calculate NDVI, you have to choose a band 1 and 4 for green seeker? Is that?
Yeah, I mean, in this case, yeah.
I think the microsense, we selected those bands because that's the closest we could get with the bands that the green seeker has for the NDVI red. Okay. But your question is interesting because really that's what I have in here, that we can try different vegetation indices combination. Like the NDVI can be calculated using the NDVI red edge, or the red edge itself is a standalone, I would say, not vegetation index, but the reflectance that is, many published work say it can be used to do a monitoring of plant health as well. But yeah, we can do a combination, and it's actually, I don't think we did that, but that's something we can do with the raw data that he has. He can expand it, but that means a lot of work, maybe.
The
Next student, they have the data already. So.
And a comment about that, the red edge camera, MicaSense red edge. The strongest of the camera is the red edge band. So it should, if you can have another student to explore the red edge band, is gonna be more appropriate because the drone is a MicaSense red edge.
So red edge is more sensitive to the vegetation variation?
I think
It is more sensitive for variation chlorophyll, but it has sensitivity when you have dense vegetation.
Yeah, when the saturation is a common problem when you
For
use
example,
NDVI.
NDVI, when you reach 85, 0.85 or higher, it's kind of all the same.
So you remember you flew the drone, camera-mounted drone in my pasture. The data is pretty, not much variation. So it was hard to, process myself. I need some help from you later. But you said saturation in the study. That means ground cover related saturation, like a certain amount of biomass accumulation, then, camera reading is not very sensitive. Is that what you're saying?
Yeah. So what saturation means is that, especially that happens in NDVI, is that there's a point where the red band cannot, it does not vary at all. And the near infrared is able to, it's kind of more sensitive, let's say. So you see that the red band will not change at all, but you see the variability in the near infrared. So that affects the NDVI. So there's a moment where it gets clogged, let's say. So even if you have higher biomass, you still get values of, let's say, 0.8, 0.8, 0.8, and you don't see the variability of higher biomass, let's say.
So biomass is not really matter for the sensitivity of the sensor camera detection range.
Maybe just with this index, maybe maybe looking for different indices can help that. Maybe a combination of different indices can do that, can help with that. But if you're just using NDVI, you will have this problem.
That's not the case for Hector because his study is like cover crop is like 0.4, 0.5. NDVI is low. It's good. NDVI is appropriate when you have until 0.7. It's 85 is bad. When you get too high,
In
But in this case, if you see
uh,
the values of his
You can
NDVI
pull
is
out
on
your values of NDVI.
0.06, 0.5, something. Because the cover crop, I mean, there's a lot of bare soil in Louisiana. I think the first graph of the NDVI values.
There.
Yeah, that one. Zero, you see, jump from 0.25 until 0.8. So it's a good range.
That's a good range, because you see that we started at 2.8 and it starts around 0.2.
Yeah,
Is it a problem that most of that higher variability is one site? Like it's site one, which was the very first year?
Yeah, you mean about there's a pooling of data in one side.
Yeah,
It's
and that
actually,
happens on a couple of different things.
Yeah. it's which doesn't matter for him, because what he needs is to see whether those two sensors are seeing the same thing.
Right,
But the pooling of that's where you have the impact of the site.
Yeah.
Or the site year for that matter. So it's not uncommon. It's common to see some pooling of data like this one site 2, site 3. And when you look at those, he got it normalized NDVI. Like you can, if you want it,
which is normalized, yeah.
you can just say adjusted NDVI.
Okay,
Whatever.
I got that in the writing and I was like.
I write the term adjusted NDVI.
Okay,
because
yeah,
it's still
that
like-
sounds good.
So when he adjusted the NDVI, it actually overemphasized the grouping of the sites. So that's what makes it, probably we should not mess up with a normalized value.
Right, well, because it's obvious in some of the ones here, but when you look at some of the nutrient or one of the other graphs, site 3,
site
like,
4,
Yeah.
right?
well, no, so this one, the bottom
Oh, okay,
right-hand
4.
corner,
3.
like all of your higher kilo biomass
Yeah.
are almost all in site 3, which is the
Yeah.
one where you had an extra month compared to 4 and 5 of growth. And so like,
Yeah.
And he did that, he did the adjusted NDVI for all these nutrients, and it turned out to be just the simple NDVI having this.
So site 3 is a more random pattern than
Yeah,
other sites.
I don't actually think it is. I think if you were to look at take site 1 out of that graph, it would fit better with 4 and 5. Cause like it kind of follows that, it's like site 1, I'm not saying one is better than the other, but like site 1 is pulling it this way, site 3 is pulling your data that way. And so
I mean,
Just demonstrate how really,
how important that kind of,
the side effect, having multiple sites, if you want to have a generalized model to describe a relationship such as this.
Can I ask what happened to site 2?
sorry.
Site 2.
What happened to site 2? You have to
have
tell her
5
the
sites.
story.
Yeah.
And in
Ah,
chapter 3, you go all through the stuff on site 2, but site 1 or site 2 in chapter 2 is in one table.
it's a long story.
Well, so I guess you don't need to tell it, but in here, you need to tell why, at least say something like site 2 had mechanical
something
error or
that-
whatever, and so it's not included in this chapter.
I got your point. That's something that I didn't know how to handle and to explain it
Yeah,
because we have some issues and we weren't able to collect readings, neither biomass.
which is in a table, which is, I was like, oh, okay, so you weren't able to, but just like a sentence or two that says like, due to mechanical error or weather events or whatever, we were not able to collect data, so site 2 is not included in this chapter, will not be discussed in this chapter. Because I was like,
Where is number?
where is 2?
But he's probably done that. Tell them what happened in site 2.
What'd you break?
Not me. But, I mean, we have this.
Yeah, we well, here's the thing.
You're not making it better.
No. I mean, what happened is before he even can go out there and collect the biomass of the cover crops, Alcoco went in and incorporated it.
Oh,
So
yeah.
the treatment for the second objective remained intact, but not for the first objective.
Okay.
So that's
For
what
the
happened.
second
So
is
yeah.
fine, right?
Well, the second is fine
Okay,
because in the end we're gonna incorporate it anyway.
Yeah, so it
You
works.
didn't get a chance to go
Well,
there.
so just like a sentence or two, you don't even have to go into like that, but like, that just says like, due to
Yeah,
whatever, we weren't able to collect this data, so we can't include it in here.
that happens.
Absolutely happens.
A lot.
Yeah, and that's why, for example, that's why I didn't.
So many times.
Especially on farm.
Hector, just curious. To me, that side 1, 2, 3, 4, 5 is sounds like more like replications to me. If you combine all as a random effect, your model will be improved or actually not. What do you think? Just curious.
If I combine all the data, or developing relationships for each site.
The size is a replication rather than
Yeah.
you analyze separate by the location sites. But if you combine, consider size as a random effect, you do the analysis again. Do you think your model may be improved with more data or actually more
Actually, it goes worse.
worse?
Because I have done it, I have this relationship for each model, and of course, for each site, it was better.
Yeah.
But that's the thing, having a model for just one site and being that specific, how useful it is. So it's more representative if you pull all of them together. But by pulling all together, you're putting all the variability together. So the model is weaker.
Yeah, I think so. Yeah.
What he was asking, I think more appropriately for your second chapter,
For the
because
second chapter.
the treatment, he's saying whether if you pull together the site because they have exactly the same treatment structure and replication, if you pull them together, because he thinks that the 5 sites is a replication in itself, which is that's the truth. You replicate in time, you replicate in
More
space.
like a replication.
But he's asking, when you look at your second chapter.
On the second chapter, I did it.
But I think
that
you're
was
right.
not
Your model would not be improved because of so much random feedback.
Yeah.
On the side.
And we did that already when we treat site as random and a fixed effect.
But I think
just
right
Come
Right
out
direction
the
is,
individual analysis that he needs to do
Right.
because it just
But
didn't. come
later
out.
his publication, the site should be handled as a replication.
Well, I would definitely suggest you should discuss what you were just talking about, how, you could do it by location, but how useful is that? So having like a paragraph where you discuss that, I think would be very beneficial, especially maybe not here, but before you go to publication of like, yeah, I can do this by site and it looks great, but
That's the
it's
thing.
very limited applicability when you move beyond this location. And so I think that's a very important concept to include in it.
But anyway, let's see if there's more questions from the audience because we were drawn to probably the defense proper. And if there's no question from the general audience, we can proceed to continue the defense program for Fajardo. But before everyone leaves, I'd like to acknowledge, of course, Dr. Fox and Dr. Luciano for serving in this committee, because I forgot to mention that during my introduction. And thank you all for coming, those who virtually attended and for those who came in person. Thank you very much. Appreciate that. And we can probably have a quick 10 minutes break before we go to the bathroom, wherever it is.
Yes, I will indicate.
And then give also Hector a sort of more of a hard time.